My name is Jeremy Morton. I've been here with Techstar for just over 5 years. Prior to that, I spent about 17 years with another company by the name of Bentley Nevada. Some of you may know it, but my whole background has been dealing with condition monitoring and vibration, everything from the sensors on the machines all the way out through the online System 1, the software platforms, things like that as well. So I came over here to Techstar, 5 years ago to help kind of build out our total reliability condition monitoring offerings here with Techstar. Techstar is a great name, great reputation out there with level and flow, lots of different types of process. So it was just a natural fit for us to kick off the vibration and condition monitoring side of the business. The two primary product lines that we carry for online monitoring would be SKF and BK Vibro. SKF is more general purpose type monitoring. They do a lot of wireless. They do a lot of smaller type monitoring systems but still provide you the dynamic data for analysis and so forth. BK Vibro is more of your API-based machinery protection systems, similar to like what you would have on more critical machinery, things like that, where you use the relays itself of the system to trip the machine offline. In addition to that, we have more sensors, transmitters, things like that, that we carry those for those product lines. We do have some small monitoring systems with those guys as well. So like if you're looking for like a small monitoring system for like a cooling tower or FinFan, STI and Metrics have really nice products to fit those needs. And the one we're going to talk about today is one that we're pretty excited to start this partnership with, and that's the Attend2 relationship. So now, we've got the bases covered from a vibration, temperature, online system standpoint. But one open area that we had was to be able to do oil analysis, both from a portable standpoint as well as online. So that's what we're going to jump into today. And we'll just kind of jump straight into the technology. So Attend2 developed this sensor actually several years ago, and it's been in use for many years already throughout Europe. But it's really unique in terms of what else is out there. And I'm going to show you some examples here a little later, but there's been laser particle counters and things in the industry for decades now. And those do a great job of just getting overall particle counts to meet your ISO standards and ratings and so forth. But there's some limitations to them. One of the key differentiator here is this is a true optical sensor. And so all the data we're going to talk about, all the different data points and measurements, it's all being calculated and done in the sensor itself. It's not being analyzed in a third-party software suite or anything like that. It's the sensor actually doing the analysis. So what the sensor allows you to do is not only just get an overall particle count for the different size particles that you may see in the fluid, but it's actually able to differentiate if it's additives, say it's moisture in the oil, or different types of bubbles and so forth. And that was always a limitation with laser, is that it included all those different types. Some may be concerning, some may be non-concerning particle count. So you may be looking at a particle count that's much higher with a laser-based technology than what you're actually running. And we're going to show you that. One nice thing about this device is there's no calibration needed. It's basically a self-calibrated sensor. So no need to send it in for calibration or certifications or anything like that. All of the software that we'll show you today, it's all included when you buy the sensor. You get the software. There's no seat licenses, no annual fees, associated with that, and you get any firmware update. So anytime they release an update, you automatically get access to them. Excuse me. And we say lab quality accuracy, but we're going to show you there's actually times where it's even better than lab quality accuracy. Most labs out there still using laser-based particle counters. So what we're going to see here, I'll show you an example here shortly, but you'll see how the optical system is able to actually give you a more accurate particle count than what the labs are able to do. The sensor itself, I don't know if y'all can see it on the camera out there, but you can definitely see it there on the graphic. You'll see there's basically two electrical connections on the front. One is for powering up the device. Basic 24-volt DC is all you need to power it up. And the other is a Modbus communications port. Fully open platform. So any of the variables that we're going to look at today, if you wanted to send it into like your internal DCS, SCADA, PLC type system, you have the ability to do that straight from the sensor without any additional hardware things added, in line. In mine is, majority of the online, they can take Modbus as an input. So now what that would allow you to do is not only be able to see all your vibration, temperature data of a machine, but you could actually map all those Modbus points into that same machine and be able to get your real-time oil health data live. So something that's really cool. I mean, it's a very open protocol. We'll touch a little on the technology of how it works. As you can see, the oil is basically passing through the sensor. There's a LED light that is illuminating the sensor, and basically a digital image processor. So kind of think of it, I guess a good way to look at it would be like a microscope. So it's basically a continuous microscope with a flow of oil through it, and it's continuously analyzing the particle counts through that sample. So as these particles come through, it's able to classify the sizes, but more importantly, the shapes of the particles. That's really the secret sauce of these guys. That database image files and everything is built internally. So no need for it to go to a computer system to be analyzed and then give you a report out. And you can see here, this is an example of what the oil looks like as it's passing through the sensor and it's being analyzed. So if you look off to the right there, you'll see different shapes and sizes of wear particles. You'll see some air bubbles in the mix there. And it actually pulls those air bubbles and things out of your total particle count. So it gives you a much more accurate, much more of a count for your, so ISO, for those that don't know, there's a standard, the ISO 4406, and primarily it's looking at the 4 micron, 6 micron size. In addition, this and 70 microns. So the algorithms and the database of online image files inside of this is basically doing all your analysis internally. So your output from this device via Modbus is those particle counts. Like I mentioned earlier, there's some limitations with laser particle counters, and here's a sample of that. So sometimes there's additives and things added to your lube oil. So maybe it's anti-foaming, and that's the case that we're looking at here. That aren't necessarily bad particles, but with a laser-based type technology, they get lumped in with the bad particle count, essentially. So here's a test that they ran, and you can see on the left side of your screen here, that's the S120 sensor that we have here, analyzing a sample of data, along with, beside it to the right-hand side of the screen, you see a comparison with a laser particle counter. And you can see that vertical line, that dashed line, where they added an anti-foaming agent. And you can see it had virtually no effect at all on the true optical sensor. But if you look at the laser-based image there, you can see there was a significant shift, a significant spike in your overall particle counts. And that's due to the limitations of that technology. So like I said, not all particles are bad particles, but unfortunately, with laser-based type technologies, they get lumped in with the bad types of particles. So this is just a slide here kind of showing you an example of an installation that looks like it was like this one was on a gearbox. But you can see this customer basically placed it in a junction box on the side of the gearbox itself. One thing to keep in mind is these sensors are vibration resistant. So vibration and things won't affect the operation of the data you get out of these guys. But you can see in this case, the customer needed, it was more of a lube oil reservoir, not a lube oil pressurized supply system. So you can see there's a small pump there in the enclosure as well to keep that continuous supply of fluid going through it. And I know I keep talking about lube oil. That's because it comes natural because of working with machinery and so forth. But these sensors don't just have to be applied to lube oil. As you can see, hydraulic fluids and lubricants, fuels. I know one application is on diesel fuel, looking for contaminants in diesel fuel, things like that, coolants, different kinds of glycols and so forth. So even though we're kind of focusing on lube oil today, keep in mind that it can actually be applied on a lot of different types of systems. We're going to kind of jump into the different types of systems that they have out there. Keep in mind that all these systems that we're going to look at here, and I won't go into great detail on any one of them, but if you have any specific questions, please don't hesitate to ask. But keep in mind that every one of these systems that we're going to talk about is using this S120 sensor. So you basically have the sensor installed in this device, and you have the various means of transmitting the data from it, whether you're looking at it locally on a display, sending it via Modbus to some sort of a system, or both. But it's all using this same sensor. And we're going to look at portable units as well. The portable units are also using the same sensor. And we have one of these kits up here in the front. This is so what we're talking about now are like your online continuous systems. This is what they call their smart monitoring kits. You can see it basically comes in a few different flavors here. On the left-hand side of your screen, one of these is basically a pumped version. So if you're putting it on like a reservoir or you don't have enough flow to be able to run through the sensor, you basically add the pump version in so that you can continuously run the right volume of fluid through the sensor. And then there's a non-pump version. So that one would be one you would plumb up in line with your pressurized lube oil system. So if the pressure reducers to be able to get the pressure down within spec, and if you, like I mentioned, if you don't have enough, then you would go with the pump version. You'll see on the right-hand side of the screen, and I think a lot of, especially down here, a lot of the refining, chem plant, type applications would probably fit more of this one. And this is their RSMK, R standing Rugged Smart Monitoring Kit. And basically, it's just a stronger, more robust enclosure housing that the S120 is mounted in, with the ability to send that data out via Modbus to your system. So you'll see we have online systems, and then this is just kind of showing you an example of what the front of a smart monitoring kit would look like if you were to go with one with the display on the front. They have the 7-inch color HMI that's touchscreen. You'll see your flow rates. You'll see your pump control, so you can speed up and slow down your pump, the amount of fluid that you're running, through the sensor itself. As well as you get the local indication of the data, as well as you're able to send the data off as well. You'll see there's also a bullet there talking about USB port for extraction. Basically what that allows you to do is go out there, run a test with a USB device plugged in, and be able to pull that data off on that USB, then go plug it into a computer and view that data elsewhere. So you have your local indication, you have your system continuously running. You want to go run a quick sample, run a quick test, quick and easy way to go do that. Yeah?
Ethernet, is it Modbus over Ethernet?
Yeah, Modbus over Ethernet. So yeah, Modbus TCP/IP. If you needed serial, we'd basically just run it through a converter and give you your RTU. And then this is showing an example of the Rugged Smart Monitoring Kit, kind of showing you the insides. This one doesn't have a pump in it, as you can see. So this would have more, I believe we have more of a pressure regulator reducer in this application. But you can actually get one with a cell modem built into it. So let's say you didn't want to mess with installing it and getting the communications established on your local DCS network or any of that, but you wanted to be able to have access to view the data remotely in the cloud. You could choose one that has the cell modem built directly in and view that data anywhere you have internet access. So, and like I mentioned, the software is all included when you purchase these systems. Now we're going to touch on the portable systems. Like I mentioned earlier, it's still the same S120 sensor that's in these devices. It's just how it's being packaged and how it's being utilized. So you'll see here on the left, this is another version of an online system, the PMK. That's one that's relatively new and coming out more, but that's more of a stainless enclosure, IP66 rated. And you can have a pump or flow control as needed. This one allows you the option of adding, if moisture is a concern for you, you want to check the moisture levels in there, you can add the % relative humidity moisture sensor in this device as well. So that allows you to gather that as well. And once again, you would have the Modbus TCP IP output on that guy. The middle device here, I think that's probably the one. I've got a lot of calls. We've done a lot of demos, and we've had a lot of good feedback on this device. And that's their FS9V4, and that's basically a battery-powered version of what we were looking at a while ago. So you have a display, and then you have the pressure ports on the, or I say the pressure ports, the fluid ports directly on top of the device there, so that, let's say you want to go out and collect a sample, you want to run it back, you want to run it through back in your lab, you can run it directly there at your office and run a quick sample. So the standard devices, you know, they do all the standard oil wear particulate analysis, but if you wanted to add moisture, either in ppm or relative humidity, you have the ability to do that. And there's also some different types of pumps you can add if you're trying to run a highly viscous type fluid. I know it's one of the questions you had asked earlier. We'll have to get the actual ratings of what the higher viscous pump can handle, but we'll definitely get that over for you guys. But one of the cool things, and this was a recent release, they just released at the end of the year. I wish you guys remotely I could show you, but I don't really have a way to do that. But now on the display itself, there's at the top left, there's a QR code up here. So basically you can walk up to the device and scan that QR code when you're running a sample, and it pulls the whole report right there on your tablet or on your phone. So from there you can email it to whoever you want. You can, you know, grab a screen snapshot and send it, you know, via email or via text, you know, out to whomever. But this is what we're looking at here is an image of what the top of the portable FS9V4 looks like. So you can see up in the top left corner, you have your standard ISO accounts, your particle counts. Like we mentioned, that's your 4, 6, and 14 particle ISO codes, basically. You see just below that, you actually have your individual micron sizes along with the particle counts on those. But you'll notice off to the right there, you'll see an additional column for bubbles. So those bubbles are not included in your particulate account. If it was a laser-based type technology, those bubble numbers would be added in on top of your particle count numbers. And you'll see at the bottom left, we have the NAS number as well as your SAE for your viscosity. If you look over to the right-hand side, we'll kind of start in the middle of the screen. You'll see you can let this system continuously run so that you're constantly trending these samples. The device takes a sample about every 2 minutes. So every 2 minutes, this trend screen will update. And if you look just below the trend screen, you'll actually see the particles and what they were broken down into, and the wear particles and what they were broken down into. So you'll see there's 4 categories there. So if it's more of a fatigue, say a rolling element bearing that's failing on you, and it's releasing more of those fatigue type particles in the fluid, you'd see that quickly, which looks like kind of what we're actually seeing here. If it's more of like a cutting wear, say you have gears that are cutting, it can actually identify those types of particles. Sliding wear as well as fiber. Let's say you have a filter that's breaking down and releasing fibers into your system. You're actually able to measure those values as well. Like I mentioned, all of this information that you see here there's Modbus registers for each one of these values. So, you know, if you decided you wanted to go with an online sensor, you could basically map these values into whichever system you want to bring them into. So.
Jeremy, Tim from Delta Fuel did clarify that the high viscosity pump handles up to 2400 CST.
2400. Did that meet the requirements for you? Cool. Thank you, Tim. Was there a temperature on that as well that you, was it?
Can that thing control temperature and keep everything at 100 Celsius, or is it not really temperature control type?
I don't believe so, but Tim, if you heard that, the question was if there's a way to control temperature going as an input into the sensor. I haven't seen one personally, but you may have one. So
'Cause this is like a portable thing they would run a sample through. It's not something we could put in the line that's already temperature controlled.
okay.
Like that's what I understand.
So this one is portable, yeah. And then these are in line. This one and the one on the end there.
Okay, so we can put that into a temperature controlled environment, and that way, all right.
We should be able to tap into the system though too, if we had pressure drop, right?
What's that now?
Like across a filter or something, if we had pressure.
You could put multiples, yeah. You could put one ahead of your filter, one downstream of your filter to check your filtration device as well.
Know if the gel particles that are a byproduct in our fluid, it's like 1% of the fluid, but they are like transparent. Would it have trouble picking up those types of particles?
That's a great question, and I will definitely get with Tim. That may be one that we'll have to have a conversation. Yeah, and if nothing else, we'll run it through a device and test it. But Tim, the question was, in their specific application, they have there's a camera, gel particles that are quite transparent. And so the question was, would these gel particles show up? I don't know if that would show as like a bubble, potentially, as you know, it may identify that as a bubble part.
The average size of them is like 30 microns.
30 microns, yeah, of the device. So yeah.
For the right size, it just doesn't know most of what, like in the pictures, obviously, you don't use transparent stuff for demonstration, but I don't know if it'll pick up transparent things.
Yeah, you know, I mean, I'll go back to that image file real quick. But you look, I mean, a bubble, yeah, if it's air, I mean, I would think.
Yeah, but this is something like you could have it in a glass jar and look at it, and you would have a really hard time seeing it.
Okay.
You would have to kind of like shake it, and you can see them a little bit.
See them then?
So,
Yeah, if nothing else, we can run a test on that fluid and see if we're able to capture that. Is it there at room temperature as well, or is it only while it's cycling?
there.
Okay.
It'll actually become more visible when they get cold.
So if you were to pull a sample, we could run it and check it. Yeah.
And Tim did respond. He said the sensor output in the portable suitcase can include fluid temperature, but can't control temperature. In the online systems, the S120 sensor will report its internal temperature, but not oil temperature gel particles if they are spheres. If they're spheres, will be counted in the bubble count, so you can trend them.
Okay. And then the other thing is, would it be able to handle, some of our oil will have a lot of bubbles in it, like it might be like, I have a picture of it, we can check it out later, but it
Sure.
probably be at least 15% of the volume.
Would be bubble, like, would it be those bubbles or of that gel, or would it be
Tiny bubbles that are, I mean, you'd be able to see them too.
air bubbles?
Yeah, air bubbles. Well, nitrogen bubbles. But
Okay. So Tim, the question on that one was they have a certain process where the fluid can be up to 15% nitrogen bubbles. And would that oversaturate it with bubbles, or would we be able to measure that? So I don't know if that's something you know off the top of your head right now that you can answer on as well.
And while Tim thinks about that, we did have a question come in from our LinkedIn live stream.
Okay.
And that customer is wondering if any of this works offshore.
Sure. I mean, so I guess that is one thing to talk about. The sensor right now is ATEX approved inherently. So if you need to install it in a more hazardous location, you would have to put it in some type of enclosure to be able to meet the requirements of that. But yeah, I mean, it would have basically any type of industry. And I'm gonna go through and show some different examples of the sensor installed right now. But I don't have an offshore example. But yeah, I mean, it shouldn't matter offshore, onshore, midstream, upstream, and you'll see we've got some mining examples here too.
Awesome. And Tim did respond. He said, with excessive air, like mentioned, it would overwhelm the sensor most likely.
At 15%. So like I mentioned, these sensors have been out in Europe for a number of years now, and we've got a load of case histories that these guys have given us that we could sit down and go over with your specific applications as well. But here's just a screen snapshot of one that was Bridgestone in Europe, and they put it on some Atlas Copco air compressors. And you'll see, it's kind of showing you an example of, you see the sensor. In this case, it was a pressurized lube oil system. And it doesn't even look like they needed pressure reducers in that image there. So they were actually able to plummet right into the existing lube oil supply lines to take their measurements. The middle of your screen there is an example of the dashboard that's available via the cloud that Attend2 has. And they can customize, I think, to some level, the dashboard, what's shown, how it's shown, you know, things like that as well. But this is a really impressive case history. So basically what they were, prior to installing these devices online, they were in a service interval of these compressors of every 6 months, having to go into them and you know, change the oil or check the oil, things like that. And after they installed these systems online, they were able to extend that from 6 months out to 2 years. Which saw a 300% expense reduction. And they had a 2-year hard savings of $208,000 with the sensors. So their ROI in this case was 6 months. It was so successful, they basically took it and they applied it. So this was on the compressor itself. They went over to the gearboxes and installed it there on the gearboxes as well. So we have some case histories for you as well as on gearboxes as well. You can see it, environmental savings is over 6,000 liters of oil. By being able to monitor it continuously and see the cleanliness of it. And then I just kind of threw in, this is kind of the tail end of the presentation itself, but here's some examples of installations to kind of give you an idea of what some of these systems look like. So like I mentioned, you know, I keep talking about, you know, the lube oil for rotating equipment, but these are just as applicable on hydraulic systems as well. And you can see here's a few different types of installations where they put them in on hydraulic units. There's the air compressor there that you'll see for the Atlas Copco. So the first image that we looked at, you'll notice that the sensor was mounted externally on the surface of the machine and moved the sensor internally to a junction box. But you can see, you know, an example there of how you're able to tap in to their existing lube oil supply line. This one's kind of hard to see, but this is installations on some gearboxes. In this case, they have the oil sensor. No need for a pump in this one either. It doesn't look like in the top left. But they did have this one going to a cellular modem in this case. So it's a 3G, 4G network. So able to bypass all your local requirements for your DCS and network security. I mean, you're now sending straight to the cloud. So. And this right on time. So this is an example of also where they've had successes with the large mining trucks and so forth. So in this case, you know, they're able to monitor the engine oil, the elevation system with the hydraulics and the transmission. They're also looking at applications on the diesel fuel for the supply to check for water contamination as well as particulate contamination as well. So, and that's. Is there any questions that are coming in on the?
I just wanted to relay Tim's previous response regarding 15%. Only half of the feedback was populated at the time where I responded. He responded that with the excessive air, like mentioned, it would overwhelm the sensor most likely if the bubble count exceeds 100 milliliter. Then accuracy drops, so we'll need to run the fluid to check the bubble counts at 15%.
Because that's something, if I were to like send you all a sample to test, like the bubbles will rise up by the time I get like a sample over here. So it seems like something, if we were to test it, it would have to just be tested in line, like at the plant. So
even if we were to pull it at the plant and go run it right away, would they already be?
It wouldn't be as represented. It needs to be represented
In line.
if we had it in line. So, yeah.
Yeah, we do have some systems that are available, you know, for testing. That's, I mean, system here as well. So it's something we want to do some more. Be happy to work with you guys on that.
Yeah.
So.
I'll have to set up like a meeting with y'all.
Sure.
We'll talk about what we need to do to see if it would work or not.
I'd be more than happy to do that. I don't know which cameras are what, but I can't see. Are we all good on the? Yeah, if any of you guys out there have questions, feel free to. Are we doing audio or is it just they have to type them in right now? just type them in.
So if we were to do, he's looking at process side and filtration, those things, but, you know, from a reliability perspective, if we had a portable, that same unit would do both, if spec'd out correctly for lube oil and for process.
Sure. Yeah, it should be able to.
That's one of them.
We had like failures with particles in that, okay.
Are you guys pulling a certain interval right now, pulling samples and sending them and waiting for results? And
We were, but I'm looking for something more
Have-
streamlined. We
yeah.
have our own filtration system, and that's my goal, is to be a little more self-sufficient. We have
Sure.
track mobiles that are very expensive pieces of equipment, and have challenges on when we should be changing oil and all those things. It'd be easy enough to
sure.
learn a little more about the oil analysis and pull some of those things in-house.
Yeah, absolutely.
So we have a wide range of uses if it's that versatile.
Yeah, and one thing to keep in mind, we're actually ordering these units, so we're going to have a certain inventory here of these devices to be able to meet, you know, the demand and stuff as we go along. So we have, I think, 2 more coming. I think in 2 weeks they said, and that they'll be here in inventory as well. So
Joey's been trying to pull me on the Stone Ages all week.
sounds like Joey.
And Jeremy, Margarita has a question. She said, "Thank you for the presentation. I have a curiosity about the particles recognition. How does it work? Are there machine learning algorithms for particles recognition? Is there a microprocessor inside the sensor?"
Yes, yes, and yes. Actually, that's a good. Let's see if I can get this to repopulate. I think I lost my screen here. Let's try this. See if that shows up. Does that one show up for y'all now? So, but yeah, actually, that's exactly how it works. There are specific algorithms internal to the sensor itself. So as it's passing the fluid under the best way for me to kind of frame it or think about it is like a microscope, basically. And as those particles pass under the fluid, there's an image processor. It's processing the shape and the size and classifying each of those individual particles based off of the database that's in the sensor itself. So like I mentioned earlier, it doesn't have to take this data, send it to a computer to analyze that, and then be able to give you the wear particle shapes and so forth. That the data you're getting directly out of the sensor is showing that wear particle information. So did that answer the? I was trying to remember all the. See, yes, it has internal algorithms. It has an image database.
That's machine learning. I don't know if it's machine learning. Is it?
Yeah, this one.
Algorithm, right?
Yeah, typically when I think machine learning, I think of like it goes through a certain learning cycle before it starts giving you the data. In this case, I wouldn't call this machine learning. That's like some of our vibration systems do that.
It's more like facial recognition almost, right? But it's not facial, it's particle recognition.
Yeah, I mean, there's no learning curve. I mean, a 4-micron, sliding wear particle that it's pretty well established in their database, so they're able to recognize that instantly without having to go through any sort of a learning period.
Yep, and Tim commented that he agrees that the AI runs every particle against a database of 200,000 image files for comparison, just like a facial recognition algorithm.
Yeah, good job, Tim. Thank you, Tim. And one thing I didn't mention on some of these devices, you're able to pull the image files. So you're actually able to this is an actual image file, from I believe a SMK. And so you're actually able to pull these image files to verify it yourself by looking to see if, the data, if you see a change or a shift in the particle counts and so forth. But yeah, it's a JPEG. It's a JPEG. You pull it right off the device. Yeah, we have fatigue wear, cutting wear, and sliding wear. I didn't put fiber on there as well, but it gives you those 4 categories of particulate shapes.
Is moisture standard or is moisture an optional, like you order?
Question. Yeah, this S120 does not do moisture by itself. You actually have to add moisture as an option. And you can get this device with moisture as well. This one doesn't have moisture, but
Is it a separate module? Like another
Yes.
inline? Or
It's another inline module. Yeah.
PPM, or what is it coming in as?
ppm and %RH.
Okay.
And stay tuned. There's some, Tim may be able to speak more to that, but there's going to be some new releases regarding being able to measure moisture and things with one sensor as well, I believe. So not quite out yet. Hopefully I didn't spill the beans, Tim. So, all right. Yep.
What was the max pressure and temperature of that again?
Max pressure and temperature. Let me see. I don't know if I had that one on this.
I saw the portable one.
Let's take a look at this real quick. I don't want to misstate. I want to say it was 2 to 10 bar, or in this case, this was 2 to 16 bar for the rugged smart monitoring kit. And the temperature, operating temperature is -20 to 70 degrees C. And Tim, I don't know if you guys have ran across high temperature applications. That may be something to address where what y'all have done to address that if you were in an application that was beyond the 70 degrees C. Cool it?
Yeah, we won't get any flow if we cool water.
Yeah, yeah, it's going to gel up on you.
And Tim just did comment that 350 bar with a pressure reducer option.
That's right. Yeah.
Okay.
So there are, we have pressure reducers.
Higher, yeah, higher.
Yeah, that's just the device itself. So if you have higher pressure, we have pressure reducers. Sorry, I should have addressed that better.
Okay.
And I don't have it in here, but I have one in my office, a pressure reducer.
Tim also commented that the oil temp can be higher than 70 degrees Celsius. It's the circuit board that needs to stay near 70 degrees Celsius.
Oh, okay, all right.
Well, the circuit board's in there.
Yeah,
The circuit board, is it all?
it's all encased in here. So
Is there any kind of cooling options, or?
not that I see. I mean, it's finned real well.
Oh, that's good.
And actually, you can take this. There's a little bit of debris there. I'll hand it over here to you guys. You haven't seen it, but you can hold it up. You can see your oil ports come in from the side, but you can look through there and just kind of get an idea. That's the glass crystals that it's running the oil through. If you hold it up to the light there, you can see right through it. So. All right. No more questions? Everyone good to go? All right.
Let me see if I have one more comment.
All right.
Tim commented that the sensor monitors its own Baird temperature and will just shut down if it gets too high. So you'd see a lack of data at that point. Internal, not Baird. Sorry.
Okay. So if the sensor itself overheats, it has a like a protection feature. And what is the temperature of the fluid you were looking?
220
220
Fahrenheit.
Fahrenheit.
So 100 C.
Yeah, we're not too far off. All right. Well, if there's no more questions. Kill it. All right. Well, thank you all for your time today. If you have any questions or comments, please don't hesitate to reach out. You can reach me here on LinkedIn or preferably send me an email or give me a call. Be more than happy to discuss it in more detail with you. And also come out to your facility and do a demo. Let's run some of your actual machinery oil through one of the portable devices and test it. So thank y'all for your time.